Hello and welcome back to Engineering in Motion. In previous lessons, we successfully built a fully functional radar system using an ultrasonic sensor, a servo motor, and a Python-based visualization interface. We didn't just detect objects, we tracked them, filtered noise, and even estimated their motion and velocity in real time. However, despite all that progress, our system still relied entirely on a computer screen to interpret the data. In real-world engineering systems, especially in automotive applications, this is not enough. A system must also provide immediate, intuitive, and physical feedback. That's exactly what we are going to achieve in this lesson. Today, we take a major step forward by introducing an 8x8 LED matrix, transforming our radar from a software-based visualization into a true embedded system. Instead of displaying precise positions, we redesigned the logic to focus on what really matters in practical applications: proximity and risk. Using a clean and efficient ring-based approach, the LED matrix will usually represent how close an object is, from distance detection at the outer edges to immediate danger at the center. This is not only simplifies the visualization, but also aligns our system with how real proximity and collision warning systems are designed. By the end of this lesson, you will have a radar system that doesn't just show data, it communicates it clearly, instantly, and physically. So let's get started. For today's project, we don't need to change anything in our Python environment. Everything will just happen in our Arduino IDE. So we can use, the Python code from the lesson number 6, because, everything will be the same. We can just easily run the code and see the result. So just go and open your Arduino IDE. It's because I updated my Arduino IDE and I am just using the latest version. That's why I am just, you can see the new GUI. Okay, so when you open your new Arduino IDE, you will see, this page, this blank, page. But, when you open it, if you open it for the first time, you will see this blank page. But if you saw, the previous screen, you saw a new you saw the Arduino IDE with the code. It was the code from the previous lesson, because we uploaded code to our Arduino IDE. But I want to tell you something, in order to just use our matrix, the LED 8x8 matrix, you have to install a library. And in order to install libraries, in Arduino IDE, you can go here on top, you can go on Tools. So just easily click on Tools. And when you click on Tools, you come to the third tab and you will see, the Manage Libraries. So just click on Manage Libraries. You will see this tab. A new tab will open for you, the Library Manager tab. And in Library Manager, you can see the search bar on top. Okay, so in the search bar, just easily click in the search bar and exactly type, what I type. You have to be careful, how I type it, capital L, and then say ED, so LED, and again Control C, Control, so LED Control. When you type it down, the first library that you can see, this is the LED control library by, Eberhard Fell. So install this library. Because I have already installed this library on my Arduino IDE, it shows you the remove button. It means that you can remove this library, but if you haven't installed it yet, you will see a button like this one's here, these libraries, install. Just easily click on install button here and it will automatically start installing the library for you. Okay, it won't take time. Just wait a little bit, some seconds, in order the Arduino IDE just finish installing the new library. But just to make sure, that it's gonna work properly, when you finish installing your library, just close your Arduino IDE one time and again open it. You're gonna, by this action, you're gonna reset your Arduino IDE. So now you can just close this library manager. So in order to close it, you can use, the Control Shift I, okay, or you can go back to the tools and again click on this manage libraries. It will close the manage libraries tab, and you can see this screen. So because we want to update the previous lessons code, and we just want to add the metrics to our radar, so we don't need to create everything to write the code from scratch. We can just easily copy and paste the previous code and update it. So in order to just open the previous code, I'm going to press the Control O. So I'm going to just open the previous code file, okay, and I'm going to close this file. So this is the file, this is the code from the previous lesson. Okay, I just didn't do anything. Let me think. It doesn't. Okay, now we can see it. It didn't just open properly. So I didn't do just any magic. It's just the code that we just wrote it together in previous lessons. I mean, in lesson number 2, and we were using it so far. We didn't change anything in our Arduino IDE. Okay, but now today we just want to add our LED matrix. So we have to add it here in our Arduino IDE. So at the beginning, in order to start, the first thing that we have to do is to call our library. So we already know how to call the library because, in this lesson, in this program, we just called it. This is the way that we can call the library. So you can just easily copy and paste the servo library. Okay, but here instead of saying servo, I can say I have to write, the library name that I want to use in this program. So the library name was LED control. Okay, the capital L and capital C, LED control. So we called our library here. That's it. And here, if we wanted to use our servo, we had to create a servo object, okay, at the beginning. So we have again to do exactly the same thing with our LED. So we have to create, an LED object. In order to create the LED object, we're gonna do the same thing like we did with servo. So we called the servo library. So here we have to call, the LED library. So the LED library name is LED control. Okay, so LED control, and I'm going to use for example, a variable name. I have to choose a variable name. I'm going to call it like, for example, LC. LC, stands for like LED control. That's the name that I picked. And I have to just tell our program that which pins that we are using for our LED. Here, like this, like what we did here for our ultrasonic sensor, we just defined the pin numbers. So now I'm going to do exactly the same thing with our LED. So I'm going to say LED, sorry, with capital LED control. Okay. Now I have to, now you can see, the color is changed. It means that everything is working perfectly. So now I have to pass it, the pin numbers. So we have to pass, 3 pin numbers here, but we also have one more, argument we have to pass, or we have to give it one more argument as well. So the 3 pins that we have to pass here is for the LED, for the LED module. But what is the 4th argument? What is the 4th number? I will tell you just now. So, in order to just write down the pin numbers, we have to pass, the DIN pin number, after that the CLK, and after that the CS. So one more time. The first pin is, for the DIN, the second for the CLK, and the third for CS, okay? This is for the MAX7219, module. So I'm going to say the DIN pin number is 12, okay? The CLK pin number is 13, and the CS pin number is 8, okay? This is the pin numbers that we connected our module to our Arduino board. Okay, so one more time. The first one is for the DIN or DIN, the second for CLK or clock, and the CS, the third one is, for the CS or chip select. Okay. But as I told you, we have to pass it, one more argument, or the fourth argument. What is the fourth? The fourth is, the for the the device number. I mean the number of devices that we are using in our project, because each 8 by 8 matrix, each LED that you have depends on the size. Today we have 8 by 8, so each device has its own number. I mean, for example, if you're using one device, you have to pass one. If you use two devices, you have to pass two. Or if you're using three, you have to pass three here, just so on. So the fourth argument, the fourth number is for the device number. So number of devices, today we have one matrix, so I'm gonna pass it one here. Okay. So this is for the first part. Okay, now we don't need to add anything else here, this is the includes and the global setup, we called it, outside of the functions and the loops. Guys, because our LED matrix is, 8 by 8, and we want to represent 4 concentric square rings from the outer border to the center. So we need to create 4 different functions. For each ring we need to create a separate function. For example, we assume that the ring 1 will be the outermost ring, in the border of our matrix. The second ring, or the ring 2, it will be the second ring, and we just we come one step inside, we will come one step inside. The third ring, will become the third columns and rows of our matrix. And the last ring, or the fourth ring, will be the innermost, the 2 by 2 block center. Okay, the center one. So by breaking each ring into its own function, the code becomes modular and readable. After that, after we create these 4 functions, we're gonna create a main function. We create a main function to just control the main logic. So this function can just decide which rings to light based on the distance level. Okay, so but first of all, let's just start creating our 4 different functions for the 4 square rings that we want to just have in our LED matrix. So here, before our void setup, okay, I'm gonna start creating my functions, 4 different functions. So I'm gonna start, I'm gonna call them ring 1, ring 2, ring 3, and ring 4. But before start, in order to start creating your function, I'm gonna start by saying void. Okay, but why should we use this void at the beginning of each function? What does it mean? In Arduino C++, every function must specify its return type. The type of value it sends back to the code that called it. Okay. Void means no value is returned. From the, if you can see, if we can see the void, also you can understand it from the meaning. So void means no value is returned. The function performs some actions like turning on LEDs or something else, but does not compute and return a result. For example, we say we want to call our first function void ring 1. Okay, void ring 1, this function draws the outer ring and then exits. It doesn't give back any number or any data. If a function were to return a distance value, we would use like this function that we created here, float read distance. Okay, so here float is the return type. So void tells the compiler this function does something, but don't expect it to return a value. It's a way to make your code clear and prevent accidental misuse, okay? So I said void ring1, so I'm gonna open and close parentheses. So you can see that the color is changed. So after that, be very careful, guys. You have each, function, you have to put each function inside, open and close, curly bracket, okay? So I said void ring1 open and close parentheses, and I open and close I just typed, open and close curly brackets. And now inside of this function, okay, let's go to the next line. I want to use for loop, okay? Why I want to use for loop? We create, a for loop to, and the for loop repeats a block of code, multiple times, okay? Let's just, write it down together, and I will explain it to you, and you will completely understand what does it mean. So I'm gonna say for, so for. Now, our matrix, indexes start from 0. I mean, start from 0 to 7, because our matrix is 8 by 8, and, in coding, in programming, you can't start, counting from 1. You start counting from 0. So if you want, for example, you have, because you have 8 by 8, it means, you have 0, 1, 2, 3, 4, 5, 6, 7, okay? So 7 means, the 8, the last, number. So I'm going to say for, now I'm going to say int, for int start from I, okay? So I say for int I, but I want to just, just loop, inside of, through, the whole, for example, the row or columns. So I'm going to say for int I equals start from 0. But don't forget about the semicolon, guys. So for int, I start from 0, but what is the end number? The end number will be the 8, okay? Because we have 8 by 8 matrix. But as I told you, we started counting from 0, so I can't say to 8. How I can say, the last number, I mean the 8? I can say I smaller than 8, okay? Smaller than 8, it means that it will stop, to 7. So I smaller than 8, okay? Now again semicolon, and I'm gonna say I plus plus, all right? So one more time, this int I equals 0, it creates a loop counter variable I and initialize it to 0, by int I equals 0, and I smaller than 8. The loop continues as long as I is less than 8. So when I reaches 8, the loop will stop, okay? That's what it means. And this I plus plus, it means that after each iteration, I increases by 1, okay? So the increment, it will increase by 1, by this I plus plus. So after the for loop, again, don't forget, you have to use, curly brackets, open and close curly brackets, okay? So here in this for loop, with this for loop inside this curly bracket, we can use it to turn on the LEDs, across a row or column. For example, I can say, LC. First of all, I have to call this, the object, the LED control object that I created, and I put it in a variable called LC. I can say, for example, LC dot. Now I have to use a built-in function. The built-in function is set LED. Okay, so LC dot set LED, but the L should be capital. Set LED. Now inside this set LED, I will pass it, 4 arguments. Okay, for the first one, I'm gonna say 0, 0, and I, and the last one will be true. Okay, the first 0, it means that we start from 0. The second 0, it means the top row or row 0 for all columns, and I start from 0 to 7, okay, with this I, and at the end we said true, okay? So what is this, what about this true? True means, that we want to turn the LEDs. on or off. If you want to turn the LED on, you can pass, through here. Or if you want to turn an LED off, you can just pass false easily. That's what these true and false mean. So one more time. 0 means, the first 0 is just the beginning. I mean, we start from 0, exactly what we did here. So for int I, we started from 0, and the 0 column, okay, sorry, the top row, I mean row 0, for all columns I from 0 to 7. So because our ring is square, we have, 4 different, kind of LCDs in each square, okay? Because the square has 4 different four sides. So we have to repeat this action for all 4 different sides, okay? So first we started with the, with the row number 0, or, the top row. Now I'm gonna just say the bottom row. The row number will be number 7, okay? So I'm gonna just easily copy this line, okay? So I'm gonna copy this line, and I'm gonna paste it 4 times, okay? So 4 times here. But now let's start. So as I told you, it was for the, for top row, or row number 7. Now I want to say, the bottom row. So what is the bottom row? The bottom row will be number 7, okay? If you can remember. And we want to say, the left column and the right column. So the left column means the column number 0. So now I can say here, instead of putting 0 here, I will put 0 I here and 0 here. So 0 I 0. And again, we're gonna do exactly for the right column, okay? So I'm gonna say 0 I, and instead of I here, I'm gonna put 7 here. So this creates, a square border. The loops ensure that each edge is lit. So what did we do here again? One more time, guys. These 4 lines, from the top, I will say top means, the top row numbers, row 0 for all columns, I from 0 to 7, I mean, with this, for loop that we said here. And the second line is the bottom row. It means, the row number 7 for all columns. And the third line, this line means, the left column, column number 0. And the last one, or the fourth line, is for the right column, or column number 7 for all rows, okay? So we have 4, rings, because our matrix is 8 by 8. So we can just do the exact same thing. We just need to change, the parameters inside, but, the basic and the logic will be exactly the same for all 4, rings. So in order to create, the other, 3 rings, I can easily just copy this whole function. So I'm gonna copy, just don't forget to just include the curly brackets. So I'm gonna copy the function. I'm gonna paste it here 1 time. And now for the second ring, I'm gonna say void ring 2, okay, for int I equal to 0. And now this time, I'm gonna just stop to number 7, because we just come 1 step inside, inward, I mean, I plus plus. Now I'm gonna say lc set led 0 0 1. This time I'm gonna say 0 1, okay, yes, 0 1 I. And then I'm gonna say true, and this time I'm gonna say 0 6, okay? So instead of 7, 0 6 I true, and this time 0 I 1, 0 I 1, and 0 I 6, okay? Because we just we come 1 step inward toward to the center. So now this is for the ring 2. We're gonna do exactly the same thing for the ring number 3. Okay, I'm gonna paste let me just copy the second ring so we won't make mistake. So I'm gonna paste it here. I'm gonna call it ring 3. So ring 3, and for the ring 3, I'm gonna say for int I equal 2, okay, for int, for int, yes, I forgot to say for int I equal 1. I made a mistake, guys, because each time we come one step toward the center. For the ring 2, it will become for I equal to 2, and I will just smaller than 6 this time. Okay, so for the ring 3, it will become 0, 2i instead of 1. I'm going to say 0, 2i, true, and it will be 0, 5, this time 0, 5, 0, 5, I, and it will become 0, I2, this time 0, I2, and this one also 0, I5. Okay, so this is for the ring 3, and I'm gonna copy the ring 3 one more time to create the fourth ring. I'm gonna paste it here easily, so I'm gonna call it just ring 4. All right, so ring 4 will become, then we don't need to just use this for loop, because we don't have any more rings here, because we only have 4 LED in the fourth ring. I mean, lights, we want to light the 4 central LEDs, row 3 and 4, and also columns 3 and 4. This is the innermost dot. Let's just delete this for loop here for the fourth ring. So I'm gonna delete it. All right. I'm gonna say now I'm gonna delete this I at the end. Okay, so let's delete this I. Okay, this I and the last I. Oh, we just deleted a number. Okay, I made a mistake. So 0 this time instead of 2, I'm gonna say 3, and 0, 3, comma, again I'm gonna say 3. Okay, 3 here, and one more comma. Okay, and this time 0 instead of 5, I'm gonna say 3 again, and I'm gonna say 4 again, true, and we're gonna delete this here, 0, 4. Okay, and I'm gonna say 3, and I will put a comma here, and this time again I'm gonna say 4. Okay, this time 4, true. Okay, and this is for the ring number 4. So what did we do here? In ring number 2, it draws, we draw the second ring, one step inside. We came one step inside. It loops, from row and column 1 to number 6, lighting the edges of that inner square. And with this, with this ring 3 function, it draws the third ring, rows and columns from 2 to 5, and the fourth one, or the ring number 4, it lights the 4 central LEDs, as I told you, columns 3 and 4, and also rows 3 and 4. This is the innermost dot. So together, these 4 functions give us a clear concentric distance indicator. So after creating these 4 functions, if you can remember, I said that we want to create one more function to just control all these 4 functions. If we had written all the LED setting code inside one large function, it would be messy and harder to modify later. Okay, so using separate functions make it easy to change the pattern of a single ring without affecting the others. So it was possible. If you ask a question, you can just put all these functions into one function, but later if you want to modify it, or if you want to debug your code, it will be much more difficult. That's why I created separate functions, and first I created 4 different functions for for the 4 different rings that we have, and I'm gonna create another function now to control the logic of these 4 functions that we created, to just to tell the program when these functions should when we have to call these functions to turn the LEDs or the rings on and off. So I'm gonna just create the next function here, the 5th function. Again, I'm going to say void, but this time I'm going to call it like show rings. This is the name of the function that I picked. But this function, it takes one argument. It takes, arguments. For example, we call it level. Okay, it's integer. So int level. So this level, it's from 1 to 4. I mean, it first it can control, the four functions, the four ring functions that we created above. It depends on each conditions that it depends, to what conditions that we define later in our main loop. It will just turn, it will call, each of these rings functions that we created above, and so it makes, the rings on and off. Okay, so we pass it, one argument. Now I'm gonna just open and close curly brackets, and inside first, let's just clear the entire matrix at the beginning. Okay, let's see how we can clean it. First, let's call our matrix object. I'm going to say lc dot. Now I'm going to use a built-in function. It's called clear display. So clear display, yes, it's correct, but just be careful. D should be in capital. So clear display. And I'm going to pass it 0. Okay, but don't forget, the semicolon is very important. I just the semicolons in our functions. I don't know why we forgot the semicolons in our function. Guys, it's very important. Don't forget about the semicolons, after each command that you write in your functions, not after the condition, the loop, this for loop, you don't need because you have the curly brackets, but after the commands inside the for loop, you have four different commands. So after each commands, you have to put the semicolons. Don't forget, it's very, very important in C++. Otherwise, you will see the error in your program when you want to run it. So I said the lc dot clear display, just to clear the display at the beginning when we run the program. Then it depends, on the level, which level we are. We want to call, the ring functions in order. Okay, so now let's just define the different 4 levels that we created the functions above. So now I'm gonna say, for example, okay, so I'm gonna say if inside the parentheses, I'm gonna say level. For example, if level greater or equal than 1, then what's gonna happen? Then we're gonna call the first function, or the ring 1. So ring 1, open and close parentheses, semicolon. Now I can just easily copy and paste this line 4 times. Okay, 1, 2, 3, and 4. So now this time, if level greater or equal than 2, we're gonna call the second function. And now this time I'm gonna say 3. We're gonna call the third function. And for the last one, I'm gonna say if level greater or equal than 4, we're gonna call the fourth function, or the ring number 4. So level 1, only the outer ring lights. Level 2, the outer ring plus second ring, because if we change the ring, if we change the level, we don't want to just turn the previous level off. We just want to keep it on. So for example, as I told you, level 2, the outer ring plus the second ring will light. In the level 3, the outer, second, and the third rings will be light. And level 4, all 4 rings, the whole matrix is nearly full. Okay, so this gives a smooth, intuitive, indication of distance. The closer the object, the more LEDs light up. So each, it depends where is the object, the position of the object, towards your sensor. Each your object get closer to your sensor, the more rings will light up. Okay. Okay, so now let's go to the void setup section. So in the void setup section, we just start serial, we configure, the sensor pins, and, we attach the servo. And we need to do, because we added our LED here today. So we need to add it here as well. So I'm gonna just say LC. I'm gonna use the library, the variable that I created. So, and I call it LC. I said LC that first let's wake up the device. I'm gonna say LC that how I can just wake it up. I can say LC. Now I'm gonna say shut down. So LC dot shut down. And I'm gonna say, so we have one device today, so I'm gonna say 0. And after 0, so for the shutdown, I'm gonna pass false. So false mean we will wake up, our device. So shutdown, we pass the false. This 0, we used it here. Don't get confused, this 0 or this 0 that we used here, because as I told you here, at the beginning. So this one, it tells our library that only one device connected here today. We connected to our program, to our board today. I told you above. And in programming and in coding, if you can remember, I said we don't start counting from 1, we start to count from 0. And because we start, because we only use one device today, and we pass the address of that device. So this device is at, the 0 position. 0 means, the first device. And if we had another one, we could use 1. So 1 means 0 is for the first device and 1 for the second device, and so on. Okay, so that's what this 0 mean. So semicolon, don't forget. And let's set the brightness at the beginning, because 0 is the minimum brightness and 15 is the maximum for our LED in this program. Okay, so 0 is the minimum and 15 is the maximum. Let's just choose something, in the middle. I think 7 or 8 will be fine. So I'm gonna say LC dot, and I'm gonna say set intensity. So set intensity, yes. Just be careful, I should be in capital. And again, I'm gonna pass the address of our device is 0. And let's pass it 8, as I told you, semicolon, very important. And the last thing is, again, we will turn off all LEDs, to start a clean program like what we did above. Again, I'm gonna say LC that clear display. So clear display, D should be in capital, it's okay. So I'm gonna say 0, because we have only one device, so we pass it 0. This is the void setup. I don't think that we need to do anything here. We finished, configuring the pins of our sensor and our servo, and also we initialized our LED as well by these 3 lines. Okay, now we can go to our void loop and to our read distance. The read distance will be exactly, the same as before. It triggers, the ultrasonic sensor and returns distance in centimeter. We convert it with this. I mean, we convert everything, the sensor data to centimeter by this formula. So we don't need to change anything here. We can just go to our void loop and see what we need to change and what we need to update in our void loop today. In the void loop, we don't need to just delete anything, because here we just, tell our servo to sweep from 0 to 180. And from 180 to 0 back again, and we increment it, by 1, and we decrease it again by 1 as well. And here we called our read distance function that we created above. So we only have to add some lines into this program today. If you can remember, here we created, the levels. So now we have to determine the ring level. For example, we have to tell our program, when we have to use the level 1, when we have to use the level 2, level 3, and level 4. Okay, we have to give it some conditions. In order to do that, I'm gonna say at the beginning, let's say, for example, we start with the level 0. Okay, let's go to the next line. Okay, so now I'm gonna say int because they are integers. So int, I'm gonna say level, level 0. Okay, level 0, semicolon. Don't forget, guys, very, very important. And now I have to just define the conditions for the 4 levels that I have. I'm gonna say if, let's start with the first level. I'm gonna say if, now if d, I mean if our distance, so if distance, for example, smaller than, we have to just pass it the distance. When we want to just see the level 1, I mean the outer ring to turn on, for example, if it's smaller than 50, okay, let's say 50, I think 50 will be enough, but we will check when we run the program. If we need to change it, we can come back and just refine it and change it. Don't worry, it's not a big deal. So if d is smaller than 50, we want to call the level 1, so I'm gonna say the level will equal to 1, semicolon. Okay, and I'm gonna do exactly the same thing for the other 3 levels. I'm gonna say if d smaller than 40, okay, if d is smaller than 40, then level will be 2, semicolon. If d smaller than just 30, okay, then if d is smaller than, if d is smaller than 30, level we call the third level, and if d smaller than 20, level will equal to be 4. Okay, so this is it. The 4 if statement, they are not mutually exclusive. They are they executed in order. Okay, for example, if d equal to 15 centimeter, it means that the d smaller than 50 is true, so the level 1 will be on, will be the outer ring will turn on. D also smaller than 40 will be also true. Also the d smaller than 30, and the d is also smaller than 20. Just be careful, guys. I gave you an example. I say let's imagine, for example, d equal to 50, so it means that all 4 levels should be on. Okay, so level becomes 4, level becomes 4, which means all rings will light. Okay, but let's imagine, for example, if d equal to 35 centimeter, then what's gonna happen? Level will become 2, because the 35 is smaller than 50, and 40, but it's not smaller than 30. Okay, this cascading logic ensures the rings represent how close the object is. The closer, the higher the level. Okay, so it means that if your object is closer to the sensor, it means that the more rings will turn on, unless it becomes, for example, closer than 20, for example, becomes 50 or something like that, then the whole LED, the whole matrix will be on. Okay, I just want to define one more condition here to say, for example, if the object become too close, let's say, for example, if it's approach to the to our sensor less than 10 centimeters, then we want to just our matrix to start blinking, and we want to decrease the speed of our servo, so the sensor will concentrate exactly on that object, and until that the object just go away, for example, a distance like more than 10 centimeters. Okay, so one more time, what I want to do now, I want to create something like danger blink. Okay, I mean that if the distance is less than 10 centimeter, we add a blinking effect. Okay, so, and at the same time I want to decrease the servo speed. Okay, already with this line, we say, you know, for each time that the loop is running, we increase the speed, you know, position by 1. Okay, so it will increase by 1, but we want to decrease it, you know, more than 1. Here we said we will decrease it by -1, but I want to decrease it more, you know, more than 1. Why? Because it will concentrate on the object. So if the object, you know, come closer or approach to the sensor, you know, less than 10 centimeter, the servo will just, you know, move more slowly. So it will concentrate exactly on that object until the object, you know, goes away and, you know, get more distance, more than 10 centimeter distance from sensor. Then after that, again, the servo will just go, you know, to the normal speed. Okay. Hope it's clear for you that what we want to do, because, you know, first of all, you have to understand, you know, what we want to do. And if you can understand, you know, what we want to just do in our program, then, you know, writing code will be much easier. Okay. So now let's say I'm going to say if, because I want to say if the distance is less than 10 centimeters. So I have to put it in an if condition. So I'm going to say if now d, let's say smaller than 10. Okay. But be careful, guys. We have to open and close, you know, a curly bracket. Now I'm going to say delay 60. Okay. For example, for 60 milliseconds, delay 60, and I will just turn the LCD, I mean the LED, the matrix off. How I can turn it off? I'm going to say LC dot clear display. Okay. Clear display. And pass it 0. Be careful. Oh, sorry guys. See, I don't know why I forget sometimes about the semicolon. Okay, semicolon. So I pass it 0. It means that, you know, our first device, because we only have one device today. If we had more, we had to just say 0, for example, after 0, 1, 2, or, you know, whatever we want. But because we only have one device today, we use 0 here. And after that, again, I'm going to say delay. Okay, for how long? Again, let's say 60. Okay, right. Let's review together, you know, what did we do here, you know, in this if condition, in the, I mean, danger blink, you know, condition. With delay 60, with the first delay 60, you know, we turn off, we wait 60 milliseconds, you know, keeping the rings on. So still the LED or the matrix is on. And then we turn off all LEDs. How? With this command, with this lc.clear display, we turn it off. And then again, we just wait for 60 milliseconds with this delay 60. Then, you know, the function ends. So on the next call, I mean the next angle, the matrix will be redrawn normally. So this creates, you know, a rapid flash that draws, you know, attention to a very close object. Okay. But if you can remember, I said we also want to just, you know, make the servo to slow down, to decrease from the speed of the servo. But we didn't do anything here. But actually, you know, we did it by this code. So in this if condition, it automatically decreased the servo speed when our object, you know, come closer, you know, than 10 centimeters to our sensor. You know, how? I'm going to tell you just now. You know, the servo does not actually slow down. Okay. Don't worry, I will just explain to you exactly what does it mean. You know, the code still moves it by the same angle step that we defined here. Okay, see here? So here we defined, you know, 1 plus 1 minus 1. So from 0 to 80, we increase it by 1. And from 180, but from 180 to 0, we will just decrease it by minus 1. Okay? So, you know, with the 30 millisecond delay here. Okay, so here at the top part here, you know, one more time here, this part we have a 30 millisecond, you know, delay. Okay, you know, but here in this if condition, you know, the perceived motion, you know, may seem slower when we come to this, you know, when this if condition, you know, start happen. I mean, when the start executing when this condition becomes true, when this if condition becomes true, the perceived motion may seem slower. Why? Because of the additional blinking delays that added inside the loop. Okay, so we have this 60 and 60. Okay, so this 260 becomes 120 milliseconds. So what does it mean? It means that it adds 120 milliseconds of extra delay whenever the sensor reads a distance below 10 centimeters. During those extra milliseconds, the servo is not being commanded to move, so it pauses at that angle. If the sensor is continuously, in the danger zone, for example, let's say because I want to just test with my hand. So let's say if my hand is very close, every time that our loop is running, it will have this extra delay and making the entire sweep slower. So this is how automatically with this if condition we also make our servo to just move more slowly. Okay, I hope this just you understand this completely, that what's happening here. Okay, and you understand all these parts. And I don't think that we have anything left. So we defined everything. We defined our functions, the 4 rings, 4 functions for the 4 rings. And also after that we created a main function to control all these rings functions. Okay, 1 2 3 4 rings function we created, and then after that we created a main function to create these 4 functions. And inside of the main function, we just created 4 different levels, and each level we just assigned a ring function to each level. And after that we call these levels here in our void loop, in our main loop, we call them, and we said, for example, we set some distances for each level. And that's all. Nothing's left, guys. Now I think it's time to go and just run the program. But before running the program, if you can remember, we always just verify our code in Arduino IDE. So now I'm gonna select my Arduino board. So Arduino board, COM5. Be careful, guys. Now I'm gonna just verify the code to see. Okay, so this is the first error that I'm seeing here. Let's just read the error, and see what does it mean. Just say true was not declared in the... Oh, guys, I just because it's been a while that we are coding in Python environment, and I made a mistake, because in Python if you want to just use true or false, the T should be in capital. I'm so sorry, I just made a mistake. True in C++, I mean in Arduino IDE, you shouldn't just put it, you shouldn't write it with capital T, just make it small. I'm sorry, guys, I'm so sorry. So true, true, true. Okay, let's verify the code one more time. Okay, let's see another error. It says expected. Oh, yes, see, guys, I forgot about the semicolon. This is when after so long, coding and dealing with the Python environment, and when you come back to the C++, you're always making these kind of mistakes. I'm so sorry, guys. Hope you just shouted on me. I forgot to put this, semicolon here after creating my object. So let's verify the code one more time and see. Oh, I don't know. This time again. Sorry, guys. Each in all, the functions, the true is in capital. Sorry. So true, true, true. And I forgot to check the color should just change. I don't know why I made a mistake. Okay, so true. Let's just go and verify the code one more time. Oh, there's another error. For the curly bracket, it's just it says, so we have this function. Okay, we open the curly bracket and we close it. So void ring 4, we just opened the curly bracket here, and so for void ring we opened the curly bracket, but okay, see, in the last function, see here, because in ring 1, ring 2, and ring 3, we had a for loop. Okay, we defined a for. So in the for loop you have to just open open and close curly bracket, but at the fourth function we didn't have that for. So I forgot to just delete this curly bracket. We only need one curly bracket. I'm sorry, guys. Let me run the program one more time and see. Oh, again, we just see so many errors again. Why? It says D was not declared in this scope. So this D, we are just here in this void loop, and you're using this D. Why it says it's not declared? We said uh, float D. Okay. See, we made a mistake. We just we declared this D inside of this for loop. So each time that this for loop, finish, so also the D variable also will not go to the, you cannot use, the D variable outside of the for loop, because each time that the for loop stops, from executing, D also, everything inside this for loop, including this D variable, also will not work anymore. So we have to declare this, D, this float D that we declared here. We have to declare it outside of the for loop, and then after that, we can use it, inside the for loop and outside and wherever you want. Okay, so let's just outside of the for loop, I'm gonna say float D semicolon. Don't forget. Okay, so float D. So now here, instead of saying float D, I'm gonna say D. Okay, also the same thing here. I'm gonna say D. And now D, I think now this time we can use this D because we declared this float D, this variable, outside of the for loop. Okay, so let me just go and verify our code one more time. Hope this time everything will be okay. Okay, guys. Okay, so everything is okay now. We don't need to worry about anything else. You see the message here. Whenever you just finish the see, done compiling. So whenever you finish, verifying or uploading your sketch or your code, you can see the successful message here, or the compiling done. So now we know that we don't have any problem, we don't have any error or any bug in our program. Okay, so let's just upload the sketch into our board. And the reason that it was the servo was turning, before that, because the previous lesson was uploaded, but now the servo is running, but our matrix is off, now. Let me, no, it's not working. So let's just go to our program and see what's wrong here. We just created 4 rings, we said int I, we started from 0 I mean, the column 0 and to 8. Okay, so it means that the outer ring, the outermost ring and after that ring 2 started from 0 to 7, and we increase all of them one by one. The third one from 2 to 6, and 4 one, the last ring, it will be just 4 center LEDs. So nothing's wrong in our in these 4 functions. And about the main function, show rings, we said int level lc clear display 0. 0 means our first device because we only have one LED today, and we just created the 4 different kind of levels for 4 different rings that we have. Okay, and this one is also correct. We don't need to change anything because the logic sounds correct so far with this 1, okay, 1 2 3 you see the logics are all correct, and 4th, the last one, and the main loop, the main function. Okay, and here at the beginning we just we turn on our LED, and the brightness we set 8, and then we just cleared the display. That's correct, nothing seems wrong. And let's go and check where we just call them. So here we set int level 0. Okay, and then we said if level 1 smaller than, if d smaller than 50, we called level 1. Sorry, I don't know what's oh, I think we forgot the about the main function, because we just using these if statements, but after that we have to call the main function, these show rings functions. So this show rings function, I don't know why we forgot to call it after these conditions. In order to use these conditions, we have to just call the functions. So let's say show rings. Okay, show rings and I'm gonna pass it level. So in this way we call the main function and we pass it the level, so it detects according to the distance, it detects which level or which ring should light. I think that was the problem, that's why we didn't see we couldn't just see the light, the LED is going on. Now let's just upload the sketch one more time. It's just oh sorry, semicolon a, I don't know why, after this, after calling the function, you have to just use the semicolon. Sorry, I forgot. Just let's upload one more time. Okay, still, the LED is off. Let's go and check one more time. So here we just called the function, and here the blinking LED condition, nothing's wrong here. So here we call these functions in the void loop. We created the float the outside of the for loop. So I think we made a mistake because we have to just use these conditions and to call this LED each time. For example, we have to say in the first for loop, one time we have to call them, for example, one time from 0 to 180 degrees, that the servo sweep, and one more time from 180 to 0 that the servo is sweeps. But I don't know why we just calling them outside of the for loop, because outside of the for loop it doesn't make sense. So we have to use these functions and these condition inside these for loops. I mean, we have to repeat it, one time in the first for loop and one more time in the second for loop. But I don't know, I made a mistake. I called them, outside of the for loops. So I'm gonna cut these functions and conditions, function and conditions. And that's correct, guys, because these for loops, they are just running the main loop. So each time they are iterating, and each time that they are running, they have to check the conditions. If the condition is true, and then they're gonna call they're gonna call the related level or related functions that we created. So after this if condition, I'm gonna say I will come to the next line, and I'm gonna say so int level equal 0. Okay, this is for the first loop. So now we are in the first loop. Let's just delete this line so we won't make mistakes. I don't know what's this. Okay. So, and this is the second for loop, and in the second for loop we also have to paste it, but we have three curly brackets. The first curly bracket for the for loop and the second for the if condition, and I think this one this one is also for the void loop. Okay, so after the second one, let's just let's go after the the serial print after this line. Okay, so after this line I will come here and I will paste it here. So okay, so this is it. Now let's just run the program and see what's gonna happen this time, and hope this time it's gonna work. Okay, see, now you can see our LED matrix. See, now it's on, and let's go. There's an object I put almost in 45 centimeters. See, now it's just the outermost ring is on because the object is less than 50, and these different objects in different distance. Yeah, let me just make my hands approach to the sensor. I mean less than 10 that we defined. So now we have to see that the LED is blinking and the servo speed should decrease. Let's check. Yes, see guys, see, this is great. Hope you can see. Now you can see that the LED is blinking and the servo is just the servo is slow very down, unless I just move away my hand. See, now the servo just running on its own speed, and one more time, see, the LED just start blinking and the servo speed, see, now it decreased. It's working perfectly now. See, okay, you can see that the LED is blinking. All right, that's perfect, guys. So, and now also let's go to the Python environment. Also, we're gonna go to the Python environment and check everything there. So we're gonna open, the previous lessons, the lesson number 6 that we created, and let's run it and see what's gonna happen here. Okay, that's great. So now we can see, both the Python and, the LED matrix. So, if, for example, by, any reason, for example, we lose the connection to our monitor or LCD and we cannot see, the radar scope and radar screen, this LED matrix can just help us in emergency, situations. For example, as I told you, you just lose your screen. You can use it temporary until you just again fix your screen. It's very useful, guys. See, let's test it one more time. Yes, and check your screen. Now I am in 3 centimeter. Let's just move my hand away. Okay, 6, 8, 9, 10. See? Okay, that's great. And 12 centimeter. So our screen is working perfectly. And also our, LED matrix. You can check, if your LED matrix is okay with the, radar scope on your Python. You can detect, the distance of the object. Now let's see, this is now the object is at 48 centimeters. See my screen? So that's why the outermost, ring was on, and so far, so on. So it's working perfectly, and we don't have any problem here. Everything works perfectly. And so we didn't change anything in our Python environment, guys. Today we did everything in our Arduino IDE, and we added one more software to our program. And the wiring is very simple, guys. We only just had 3 pins. The other, I mean, we had 5 pins, but 2 of them were VCC and GND. You already know that you have to connect your VCC and GND to the 5-volt and negative side of your breadboard. So only 3 pins left, and I told you, we connected them to pins, number 12, 13, and 8 on our Arduino board. And that's all. Hope you just enjoyed today's lesson, and hope you learned something new. Please let me know if you have any question or if you have any doubt. I will see you in the next lesson.